Hello. So for this demonstration, I'm going to show the power of Emulate3D when coupled with independent cart technology, or ICT. Emulate3D is a all-encompassing software that shows not just independent cart technology, but gives you the ability to demonstrate quickly adding in components, whether they're conveyors or other systems, and it allows you to demonstrate what those capabilities are using a real-world physics engine. In addition to that, you can pull in CAD models and add aspects to them so you can actually bring your machines and your CAD models to life as well. Taking that even one step further, you can connect them with an I/O browser to a PLC, and now you can emulate your CAD models and what essentially becomes a digital twin of your system. So overall, Emulate3D has quite a number of features, but the one that we're going to talk today about is independent cart technology, or ICT, and how that fits in within the Emulate3D world, and what I like to consider the proverbial easy button, and you'll see what I mean by that in a moment. So in this window, this is my Emulate3D window. I have a number of catalogs. So I mentioned previously, you can take in different types of conveyors and drop those in. There's a whole number of different items that exist within Emulate3D. A lot of catalogs, very, very large list. But today, we're going to look at just the independent cart technology. So I'm going to build a couple different items from independent cart, one being an iTrack and the other being a Magnemover light track. And I'm going to show you how quick and easy it is to put together a track and demonstrate this for customers or just for your own benefit. So we're going to start by dropping in an iTrack controller. This controller is what allows us to identify all the different pieces of that track and helps that track work together. Think of this as your Logix processor controlling that iTrack. So now we're going to start dragging in sections. And we can click and drag different sections in from the window to the side, or we can highlight one and we can kind of take and drag it away like that. And if you'll notice, there's a little red square that pops up, and that little red square allows the pieces to snap onto each other. I can take one section at a time. I can take multiple sections at a time like that to make larger tracks. I can add in curved sections. And again, I can take and click and drag the entire track over to make one quick little track like this. I'm going to point this controller to the track, so now it knows that this is the track that I'm controlling. And furthermore, if you'll notice, it says 0 section there. This is telling me this is my 0 section, so now I know in my overall iTrack loop where 0 is along the track. So now I have a track, right? I need to add movers to it. I can see in my catalog I have a number of movers, but one thing that also shows up as soon as I drag in this iTrack controller is up here, this ICT ribbon. And this ribbon is going to be where all of the power of the independent cart technology framework inside of Emulate3D lives. So you'll notice a couple items here. You have visualization, bill of material, track configuration, but the two that I'm going to showcase right now is mover configuration, and a little later, this PLC button. So let's start with mover configuration. In here, I have the ability to bulk add movers. So whereas I can click and drag an individual mover in here from the side, I can also add a number of movers all at once. So 10 sounds like a good number. We'll start with that. We're going to choose what type of mover I want, and this depends on what type of iTrack I have. What I was dragging in earlier was the iTrack 5730, or what we call the iTrack small frame. The other iTracks, the 50 millimeter sections, the 100 millimeter sections, those are iTrack medium frame, and those have different movers that you can choose as well. So I'm going to select the small frame iTrack, the 5730s, those movers. I'm going to bulk add. And now you see all those movers just popped up onto my scene in Emulate3D, but they didn't load themselves onto the track. But that is because this iTrack controller has multiple different configuration settings to it. One of them being desktop simulation mode. So the difference between a simulation and an emulation, simulation allows you to use just Emulate3D. It pulls in only Emulate3D information, and this is how the track can move and work. And that's what we're going to do to start with. But emulation is a little bit different than simulation in that now I can add in a controller. I can add in a PLC to the mix and have this just be the 3D visualization of what my controller is doing. So as the controller is saying, hey, these movers are moving and they're at this location on the track, that is where the movers are going to visually show up on the track. By default, this iTrack controller is set up for false on simulation, which means it's true on emulation. So I'm going to change this to true because I want to start by simulating. And now my movers have jumped onto my track. So this gives me the opportunity now to see the movers move. But where are they going to move? So the next thing that I need to do is I need to add in stations. I need to add in waypoints, stop points, whatever you want to call them, along the track to say this is where the movers are going to move to. So I'm going to add in one right over here. I'm going to add in one, let's say, over here. And I'm going to add one on the back side over here. Inside of each of these stations, I have a number of different configurations here as well. I can choose the station to be a bypass, which means the movers aren't going to stop. They're just going to fly right through. I have the ability to set the minimum gap, meaning how close can those movers get together. I can set what the next target is. Where is that mover going to go next after it stops at this station? I can say set a process delay. How long is that mover going to sit at that station? For a simulation effort, this is great because this gives me all the bits and pieces that I need for this station, which I'm going to eventually want to put into a Logix processor. For a process delay standpoint, this works well for simulation because I don't have any additional external forces. I don't have a robot picking product off my mover, for example. So I don't have anything else to say, hey, you're able to move to the next station. So I can set a process delay to simulate how long I think it's going to take at that station. So let's look at this and say, okay, station 0 has a 500 millisecond process delay, a half a second. I'm going to leave that where it is. That's great. Station 1 tells me my next target is 2. Okay, that makes sense. And my process delay is 500 milliseconds again. Let's set that to 1 second, just so we see a little bit of differentiation. If I zoom around here to station 2, station 2 tells me it's going to go to station 3, but I don't have a station 3. So I'm going to tell that to go back to station 0. That way I complete my full loop around. I'm also going to give this a slightly longer process delay, let's say 2 seconds, but I'm also going to change my speed. This is the speed at which it will arrive to the station at. So I want this to fly from station 1 to 2. I'm going to tell this to go at 2,500 millimeters per second with an acceleration of 5,000, or deceleration and acceleration of 5,000 each. Okay, so now I should see a slower transition, a fast move over here, and then back to a slower move. And let's see how that all works. So now that I have all the stations in here, I can come back to my home, away from my ribbon, I can hit reset, and I can hit play. And let's see what it does. Moves to 0, moves to 1, then it will fly to 2 with a slightly longer delay. You can see a little bit longer of a delay here than it is over there, and even a little bit longer of a delay over here than it is there. But this is exactly what I just set up. I now have a working iTrack, but what I also want to do is show you all what a MagnaMover system looks like in this system. So we're going to move over on the scene over here, and we're going to go back to the base ICT folder, and now I'm going to pull in a MagnaMover. Let's drop in a MagnaMover light controller. This is a similar controller to the iTrack. So again, think of this as your processor, but in addition to that, it has a couple additional features because MagnaMotion has other components to it than just a simple iTrack. So I have global settings for my setup. I have path settings, and I have node settings. All of these together make up the one MagnaMover-like controller. This would be a simulation version of your node controllers, your high-level controller, as well as the PLC. So I now can start building my MagnaMotion track. Similar to the iTrack, I have different components that I can drag and drop in. I can bring in a straight section here. I can bring in a quarter meter section, so a 1 meter section and a quarter meter section. I can drag in a number of 1 meter sections. Let's just drag a couple in here. We're going to make this track kind of larger. Let's drag in one more over here. And then let's start making some curves. So just like with the iTrack where I have curved sections, I have a curved section here as well. I'm going to make a curve over here. Let me zoom in so it's a little bit easier for everybody to see it. And I'm going to add in a couple straight sections. I can again click really close to it and it will snap into place. I also have the ability to use my scroll button on my scroll wheel on my mouse, and I can rotate it as well so it gets into place. Either way, I am building my track. So as I'm building this track here, we have multiple different things we can do that are different between a MagnaMover Lite and an iTrack. With an iTrack, you have your straight sections, but you also have curved sections that make up either a full loop. We can make rectangles with iTrack. We can make so straight lines, rectangles, squares. You can make some different shapes like that. But with the MagnaMover, you have the ability to be a little bit more open with the way that your shapes are. So you'll see what I'm building here is like a process spur. So I have the ability to do switches, which makes one path turn into two. This would be considered a diverge point. And just because of that, I'm going to add in a diverge point. This tells me that I'm taking one path and I'm going to split it into two. So I'm going to continue to make my track the same way that I did before with the iTrack, but with the MagnaMotion components. And I'm going to close this. And now I'm taking these two paths, I'm going to make them one. So I can add in a merge point, which I guess I got to add the other track first. Let's do this. Let's take in this guy here. I'm going to delete out that diverge really quick because I want to take all of this and I don't want to keep the merge with me. I'm going to make a handful of these spurs. So we're going to make 1, 2, let's do a third, and just because, let's make a fourth because my track looked like it's just about long enough to do that. It's actually the perfect length to do that. So now let's close this loop. So we have a solid track in here. And right like that. Okay. Now let's add back in that diverge. So in addition to using these diverge and these merge points, you have multiple different types of nodes, and that's what these are called, are nodes. Diverge means one path splitting into two. Merge means two paths splitting into one. A merge diverge is a point at which you might have two switches side by side, or a way in which that path can be both a merge and diverge. You also have terminus nodes, which is a means of exiting the track. Simple and relay nodes are other additional nodes that separate multiple paths. I'm going to take this MagnaMover-like controller, and before I forget, I'm going to point to this track over here. This again tells me where the zero section is of the track. And now I need to do something else within the iTrack or within the MagnaMover. I added that one node, and I can click and drag in all of these nodes, but I also have the ability in my ribbon up here to take in the track configuration this time, and I can assign the track. In the MagnaMotion world, we also call this walking the path. So I can click on my first node here, I can hit assign track, and it automatically will add in the rest of the nodes. It does that because I defined this first node as a diverge. So now I have defined the flow of traffic along my track. I know my track is going to move this way in the forward direction. It's going to diverge into two paths. And so therefore, the system automatically knows that the rest of these are merge and diverge points. I have now assigned my track. I also can add back in the movers. So let's add in some movers here. This is a slightly bigger track than over here. So maybe instead of 10, let's add in 15 movers. Why not? Again, we have to choose the type of mover. We can hit add. Just like before, they kind of showed up in the middle there, but we're going to change this over to simulation mode. They're now on my track. Okay, just like with the eye track though, we got to tell it where do we want to go. So we want to add in stations. So let's add in a station 0 right here, a queuing station. We're going to add in a station over here, and we're going to use that bypass feature for this that I showed you very briefly earlier. We're going to add in process stations. So the idea with MagnaMotion and being able to do these different paths and these different process stations, if you will, these different spurs, is it gets you the ability to do parallel processes. What I mean by that is, let's say at one of these stations, it takes 16 seconds to complete. But I want to be able to have a vehicle leaving at my unload station over here every 4 seconds. How do I do that? Well, if I have 4 parallel processes and it takes 16 seconds for one of these to complete, I'm still going to have one every 4 seconds leaving over here. So I still am able to meet my throughput goals. So I have 0, again, target ID, next target ID is 1. I can tell it where I want to go, the process delay that I want here, my XL, decel rate, all of that good stuff. For this guy though, I'm going to make a couple changes. I'm going to change him to be a distribution station. A distribution station, think of it as a dealer station. I now have the ability to assign substations. I can tell this guy, you are a substation. You are a substation. All of these are going to be substations, and this guy is going to evenly distribute, hence the name distribution station, to each of the substations, and he is going to, every vehicle that comes past him, he is going to find the next available open station, and he's going to deal the vehicle over to that station. I want in here this to be set to auto bypass. I don't want my vehicles to stop there. I just want him to be a dealer. So I'm going to set auto bypass. I do need to tell each one of these vehicles that they need to go to station 6 next. So instead of 2 going to 3, I want that to go to 6. And because I can click and highlight multiple at a time, I'm going to highlight the rest of these. And I'm going to tell all of these, my next target ID is 6. So now each one of these is going to send it to 6. 6, I want to send to 0. And to show what I was talking about with the process delay times, you can see that in here, the process delays are set to 500. I'm going to say, take all of these and let's set them all. I'm not going to do 16 seconds because that's quite a long time. Let's just do 1 second. Or sorry, 4 seconds. Okay. Now I can hit reset and play. And we'll see all these vehicles moving. You can notice my eye track is also still moving, but these vehicles are going to all move to 0. They're going to bypass 1, and you'll see something special here when the vehicles come past 1. They're going to all distribute evenly to each of their given stations. They're going to automatically queue behind each other as they go. And now, because of this, I have the equivalent of one vehicle every since I have 4 in the 4 seconds, every 1 second coming through here. Okay, so that's great. That did what I wanted it to do. Now, we are going to add in another feature, which is the ability to emulate some of these tracks. So for the sake of time, let's just pick our eye track controller. We're going to take this eye track controller, we're going to change him back to false on the desktop simulation mode. What this gets me the ability to do is now emulate. I have an I/O browser. This I/O browser is what connects Emulate3D to my PLC. you'll see that right now it is empty. So now I'm going to click on my iTrack controller, come over here to my ICT ribbon, and I'm going to go on this other PLC button that I mentioned earlier. You'll notice a couple items here. The first is this PLC connections. This is what allows the iTrack to control the iTrack controller to add in all of those connections in the I/O browser to connect to my PLC. If I know what the IP address is of my PLC, which I happen to know exactly what it is, I can put that information here. I can hit generate connections. And now if I come back over here, you'll see a connection point with my tags. These tags are PLC tags that will exist within the controller. So when I have my PLC controller, I now have the ability to read or write these tags. In this case, they're all read. I have the ability to read these values, and this iTrack will now mimic what it is seeing from those values. So I'm going to close this down, and then we're going to look at what I believe to be the easy button, as I stated earlier. This gets me the one button press to generate my PLC code. I want to reiterate that one more time. It is a single button press, and it will generate the PLC code. What that means is I can choose to generate directly to an ACD file and load it right into Studio 5000. If I were to do this, I can hit Generate Project. It would create the ACD file. I can download it into a processor or another digital engineering tool such as FactoryTalk Logic's Echo, which we'll talk about in a little bit here. I can load it directly in. I can hit play, or rather hit start on my I/O browser. It will make the connection to that processor, and then I can emulate my system. I can also take this and bring it into Application Code Manager, or ACM. For what we're doing today, that is what I'm going to do, because I want to show everything that would have to go into ACM to make this iTrack work. So I can choose ACM. I can choose what my target controller is. I am going to be loading this into FactoryTalk Logic's Echo, so I'm going to just choose an L85E, which is the default selection. But you can see a number of different processors that I can choose from to generate to. So I now have everything that I wanted here. It's an ACM. So now I can hit this Generate Project button, and I can generate the file. You'll see I already have a couple in there, but let's just call this iTrack E3D demo. I'm going to save this file, and what this just did is created an XLSX file, or an Excel file, with all of the information that can get loaded into Application Code Manager. So let's do that now. So we're going to go into Application Code Manager, and we're going to go to Tools, Import Export Manager. We're going to hit New because we want to create a new project. We're going to find the file that I just saved, which is right here. We're going to hit Open, and we're going to hit Import. Now this takes a minute, but what it's going to be doing is taking in all of that information that E3D exported. You'll have to hit Next a couple times, but it's going to add in all of that information, import it into Application Code Manager. And the outcome is going to be a project that you're going to see over here with all of the logic written. I'll hit Finish, and we'll see all of the logic is written. All of the AOIs are added in. If I open up in my tasks, I can see my device handler. I can open up this task. I can see my startup sequence and shutdown sequence. I can see all the station logic in here. Everything has been added in automatically. All of this information would have to be added in by hand using the ICT libraries and Application Code Manager in order to create this iTrack. So you can see very quickly here that with just a simple push of a button, I was able to shortcut several hours worth of work and the potential of fat finger errors. So this actually does save a lot of time and engineering costs. This is something that's very useful to show off to customers, and it's kind of the drop the mic wow moment, if you will. All right, so now that I have this track in here and set up, everybody's happy. This all looks great. Now I want to generate this controller. So now I'm going to come over here. I'm going to hit right click and I'm going to hit generate controller. I'm going to create the ACD file for this guy, and we're going to put him on my desktop. Wherever the desktop is, there's the desktop. We're going to put him on the desktop, and I'm going to save this ACD file. Now, this does take about 4 to 5 minutes, depending on the size of the eye track, depending on the size of the file that you're exporting. So for the sake of this, I'm going to fast forward through this part of the video to save you all time from having to watch a progress bar across the screen. Okay, so again, thank you for sticking with us while I fast forwarded through that section. That took, as you can tell, about 186 seconds, plus the 11 seconds of creating the L5K. So overall, just under 200 seconds to create. But again, it's well worth the time. All right, so now I can hit open folder and I can see my file right here. I'm going to open up this ACD file. With the ACD file opened up, we can now see that everywhere within the processor, I have all the sections added over the Ethernet network. I have all the movers, all the sections in my motion group. I have all of the routines, all the logic that you saw previously here within Application Code Manager, here within Logix Designer. Now, one thing to note is, if you remember when I was in Emulate3D, I stated the IP address was 192.168.44.128, and it was slot 3. This has me in slot 0. So that is one change that I'm going to do. I'm going to come into the Properties section. We're going to change this to slot 3. Okay, we're going to save this file. So now it is saved. Okay, we're going to close it down, and now what we're going to do is use another digital engineering tool called FactoryTalk Logix Echo. This is the means of downloading a processor, multiple processors, into multiple chassis that can all work together. This is the means of doing this to couple up with Emulate3D to save you from having to have a physical chassis and a physical processor with you. And for the customers, this is great for today's supply chain world when it's hard to get components right away, because this is software and it is available immediately. We're going to hit add from ACD file. So I'm on my desktop. I'm going to add my ICT folder file that I want right there. Hit open. I'm going to choose my IP address. As I said before, 192.168.44.128, slot 3. We're going to hit add. What this is going to do is add my processor in the proper slot, and it's going to show up over here. I now have the ability with a key switch to download to that processor. So let's do that. Let's open back up this ICT program. Okay, so with the program back open up, let's download it. Let's first set the right path that we want to use. We're going to go to the RS-Who window for FactoryTalk links, the Who active. Okay, we're going to find our Emulate Ethernet, and we're going to find 128, and we're going to go to slot 3. This is our path, and we are going to download. I'm going to fast forward during the download process to save you guys time from having to watch. Okay, so now with the program downloaded, you can see we're in remote program mode. One of the cool things you could do with Echo is, I mentioned it has the key switch functionality. I can see the project is loaded in. I can take this and turn it into run mode. Let's put it back into remote run though. Okay, now with this in remote run, we're ready to link this to Emulate3D. But there's a couple things we have to do first off. The first thing we need to do is we need to tell the eye track that it's a virtual. The reason being, I don't have a physical eye track in the room with me. So we're going to call this a virtual track. It's now going to slowly make its way to connected and idle with the DC bus. It's now ready to be started up. Let's jump back over to Emulate3D. Let's verify that this is in desktop false for desktop simulation mode, which it is. Let's go ahead and hit the I/O browser and let's hit start. It should now make the connection to go green to be able to read everything that it sees on the processor, which it does. We're going to close this down for now. We're going to hit reset and we're going to hit play. And you'll notice all the movers moved on top. The reason why is because it doesn't know where those movers exist because we still need to do the startup on the track. So let's come back into the program and let's do a startup on the track. These tags, by the way, that I'm manipulating in here are simply something that you can have from an HMI or any other device, and the customer would be interacting with these with the rest of their machine code. But for this demonstration, we're just going to toggle the bit. We're going to see this go all the way to the startup sequence. And now, if we look back, our movers have moved to certain locations. If I open up the I/O browser again, I can see positions in those movers. I want these to start moving into those stations. So now I'm going to come to the station coordinator and I'm going to turn on my stations. Now with my stations enabled, if I come back in here, I will see the eye track doing exactly what I had asked it to do previously in the desktop simulation mode, but now I'm emulating. I can prove out that I'm emulating because I can look at my I/O browser and I can see the various status bits coming back from my controller that this is reading off of. So in addition to the I/O browser, we can also prove out that this is really reading off of the controller by changing some of the values at the station. So let's, for example, say, let's change the speed from 0 to 1, or the speed that it leaves station 0 with. So we can come into here, we can come to the different station points, and we can change what we want our speeds to be. So I can see station 2, station 0, and station 1, and I can see what each of those values are. So right now, it leaves station, or arrives at station 2. It arrives at station 2 at a speed of 2500 with an XL and decel of 5000. It arrives at station 0 with a speed of 1000. It arrives at station 1 with a speed of 1000. And it's got different process delays at those stations. And you can see the process delay here is taking quite a bit of time. So let's make that go a little bit quicker. Let's go to station 2. And instead of 2 seconds, let's make that down to a half a second again. Now the movers are going through there at half a second. Let's make station 0 go to 1 second on the process delay. And now you can see it sits and holds. So now you can see that I truly am, from my processor, emulating my code. So that is the end of this current demonstration.